the sort of the common things about the Lab 3 solution. So this is off the Git page. It's driving me nuts. There we go. Okay, so here's what I did for my unit tests. I made a bunch of students. Some people had students with actual names in it, like Joe, Pete, Frank, Fred, and all of that. And that's okay, but the problem comes when you start adding and removing people. It's hard to keep track of who should be left, right? So if you just use something simple like A, B, C, D, E, then if you've got A, B, and C on the list and you remove B, then you should have A, C, and D should come off the waiting list, right? So it's fairly easy to talk about it that way. It's difficult if you've got Joe, Pete, Mary, Sam, and you're moving people on and off the list. Okay, so it really doesn't matter what the guts of the thing are here. The important thing is that you've got some bunch of students. If you look at what I did for the position on list, this is just testing to see whether people end up where they're supposed to be. So I tested people who were actually on the list and people who weren't on the list. And then to check to see whether or not sign up worked. The thing that most people missed was when they signed people up, they just tested the counts of things. And you not only have to test the count of things, but you also have to test to make sure that people end up where they're supposed to on the list, in the right order, on the right list. And so notice in my initial test for sign up, once I knew that position on list actually worked or sign up worked, I signed up one student. I said, well, okay, this number of people who are signed up should be 1. There should be nobody on the waiting list. If there was, that would be a problem. The person who's in position 1 on the list should be, or so the person in position 1 on the list should be a student. And then I turned around and added another student, and I said size should be 2, nobody on the wait list, first student is still on the list where they belong, second student should follow them. Okay, and I did the same thing for third student, and then when the wait list formed, I checked to see that there was a wait list, it had the right count, and everybody was in the right place. Okay, so it's not a complicated test. It fits fairly nicely on one page, but there's all of the components that make sure that you're meeting the requirements of what your expectations really are. Okay, and so testers really do have a bad time of it, of trying to think of what am I really expecting, because sometimes you miss the subtle things, and after a while you just get good at going, okay, these are the sorts of things that I should really double check to make sure that are there. After you've checked to make sure that sign up works, in the next test it's just fine to go back and do a bunch of sign ups and then start to do something else. In this case that was the old test to see that the wait list was used, but I even modified the original test to now include all of the position on list stuff, at least at the end, to make sure that people ended up where they were supposed to be. Okay. Back to the other classes, student really didn't change. If we go look in section, there's my section with a name and maximum students, and these are the two things that changed from integers to lists of people. A lot of people tried to initialize things up at the top there. The syntax for Java allows you to do that, but if you start to mix and match and do some of the initializations up here and some of them down there and don't do the ones that are defaults and do them in funny orders, it just gets really hard to follow when you have a lot of variables in play. And so what I've done is I've made sure I did just the declarations here, just the initializations in the constructor, and I've done them in exactly the same order. So it's really easy to go, oh, where was waiting declared? Oh, it's the last one here. It's going to be the last one in that list. Okay? It just keeps things tidy. There's no rule that says you should do that, but when you look at other people's code that don't, you'll find that it gets sort of messy to deal with. The getters are really sort of boring. We've reached the point where there's not much interesting in them, other than that the one trick here is that you no longer need to keep track of the number of people who were in the class because the list will do that for you. Okay, so the instant you find somebody else who can do it and who's already doing it, it's like, no, I don't need to keep track. Some people were trying to keep track of the numbers themselves, and then the list was keeping a count, and it just gets messy. So it only needs to be in one place. To sign somebody up, the trick is always in the code we write is just to ignore that and move right on down and go, well, what else is in there? There's the thing, when somebody signs up, we just add somebody onto the list. That's all there is to it. And so the normal case is just sitting out there where it's supposed to be. The special case is, oh, if for some reason we've reached the maximum number of students, then we just put somebody on the waiting list and we're done. Okay. Withdraw. The same trick here is you go and you look and you say, well, what's the normal thing I expect withdraw to do? Well, somebody should be removed from the signed up list. And there it is. It's not inside an if statement. It's sitting out there all by itself. Okay? In order to find out which position was necessary to remove, I went and I used my some position on list thing that did the work for me. Okay, and so it just says, oh, I found them at this position, so it does the matching, and when it finds them, then I remove them. And now after I've removed them, it's like, well, okay, if I've removed somebody, I wonder if there's anything that's changed, any cleanup I have to do. The cleanup is, oh, there might be somebody on the waiting list I can grab and move over. Okay, so I finished with the removal, and then I moved on to saying, is there a waiting list? Well, if there's no waiting list, nothing to do here. Reject that, and then move on to the cleanup that says, oh, I guess there is somebody I can steal from the waiting list. So I'll go get them. So three-stage process. Let me go find them first, take them off the waiting list, or go get them off the waiting list, remember who they are, remove them from that list, and now go add the person who was on the wait list onto the signed up list. The big issue there was a lot of people took waiting.getZero and ended up plopping it into here. Okay? And if you do that, then you have to remove, you take the remove, you can't do that there anymore because that would remove them from the list before you actually go add them. So you have to slide the remove down, and that puts things sort of in the wrong logical order. Okay, so it puts it in the wrong logical order. The other issue here is that if you just put waiting.getZero inside here and you don't give it a name, people don't know what the zero means. It could be any number because it's just this rather arbitrary expression. Okay. The second issue with putting waiting.get in there is that people are going down the page like this, one step at a time, reading simple things, and now all of a sudden you're forcing them to go right-hand side of the page, inside out, reading backwards in order to figure out what's going on. And this is just a simple case. Some people write functions within calls to functions, and then it just becomes a mess. Okay? So, if you give the thing a name like this, and you accidentally put the wrong number in there, like 5, the next person who sees this code, or you when you see it, will look at it and go, well, hold it, first doesn't mean 5. Okay? And the second thing that happens is if for some reason you choose somebody instead of off the waiting list, if you accidentally choose them off the signed up list, then it also doesn't make sense because the left-hand side says waiting list and the right-hand side, if it said signed up list, you'd go, well, hold it here, this doesn't make sense. Okay? So the whole idea is that if you announce your intentions with a variable of what you're trying to do on the left-hand side, then it's a lot easier to figure out how you're supposed to do that on the right-hand side. You'll probably get it right, and the next person who goes and looks at this thing will know exactly what your intentions are. So if your intentions are this, but you do something else on the other side, they know what to fix. If you just put some arbitrary expression in there, people have to unroll what's your intention in order to figure out now how to fix it and then go back and see whether or not that matched your intention. Okay? So it's a more involved process if you don't let people know what you're doing. Okay? And this is another one where all the old guys will just go and plop that thing right into there, and they'll go, oh, that variable, that costs a lot. You know, like that's going to be really expensive. They're not expensive anymore. Don't worry about it. The compiler will probably make that thing go away in the long run anyway. Okay, so remove the person and then add them to the appropriate list. So that's the trick with that one. Withdraw from waiting list is sort of the same trick here. Okay, here's go find somebody's position on a list. It's like you're given somebody who looks like the one you want. You're given a list to search. That's either going to be the signed up list or the waiting list in our case. So it doesn't matter which list it is, the search is the same for either list. So what we'll do is we'll go drag out the first name and last name of the lookalike person, and then we'll go through all of the people on the list. We'll retrieve the next person on the list. If their first names don't match, we're done. We can go back up to the top of the loop. If their last names don't match, we can go back up to the top of the loop. Oh, guess what? If their first names and last names don't match, I've got no reason to reject them. They must be the same thing. Okay, so notice that even inside the loop, I wrote this thing almost exactly like I've been writing methods for you, that same rejection style, right? The good thing to do is, oh, they just match, and then the restrictions are up above, and they just go basically get you out to try again. Okay, so it's exactly the same little pattern, and if all else fails and you've gone through the entire thing, then you're only left with, I guess they're not on the list at all. And notice I specifically wrote -1 there. I didn't assign a value. I said, no, if you get to this point, I know it's -1. It's not in a variable. That's your only choice. Okay. Some people tried to do the for each thing here, and they discovered the problem with for each is that for each doesn't count. And so now you have to add another variable up top in order to count every time the for each is going through, and it just sort of starts to get all twisty. And so the easiest thing to do is recognize if for each isn't useful for counting, why don't I go to a counted loop which is useful for counting, and it'll keep track of the position for me. And so you can use the loop control variable there, and it's much better. Okay, so there's that little rule again. When you find yourself sort of squirming to do things and going, oh, this isn't quite working out right, it probably means that there's an easier or simpler way to do it if you stop to think about it. Okay, so originally I had you write the code for getting the position off somebody on the signed up list, and I said copy and paste all of this code in to here to start with. And I had you write this one afterwards as merging the two pieces of code together. Okay? The reason I had you do that is because that's typically how code evolves. People do this cut and paste thing. Oh, there's some code I can use, let me paste it in here. The problem with cutting and pasting of code is that if there's a bug in this piece of code, you might not necessarily fix that bug in the copy and pasted piece of code, particularly if you copy and paste someplace farther down rather than right next to each other where it's more obvious that they're duplicates of each other. So the rule is, anytime you find yourself doing cut and paste of a bunch of code, you're better off to say, why don't I put that thing inside a method so that more than one person can use it, and isolate it to just one copy of the code. Okay, and so that's what's happened here. Now position on list and position on wait list is really easy. They make use of the same routine, still searching for a student, and they just give it a different list to search. Okay. I also sort of tried to mess you up by talking about, oh, the outside world needs a one-based solution, so it would be nice if position on list, if we're going to use it to actually display things, if it returned a one-based number. Okay. Some people wrote code inside here that started to say things like I+1 or I-1 to try to get the 1 to work. That tends to be a bad thing to do, because if you have some variables that are index variables that are based on 0 and other index variables in the same program that are based on 1, then you no longer know which ones you should be adding 1 or subtracting 1 and which ones you shouldn't, and it starts to become a mess. And it's a real bad source of errors. Okay, so the sneaky thing is to just leave everything zero-based for as long as you can, and then at the very last moment when it's required, you all of a sudden convert it to a one-based number. Okay, and I put the 1 on this side just to make it a little more obvious that the 1 was being added, to make it a little more clear. Okay, in real life, I would actually never do this. The conversion of zero-based to one-based would occur in the GUI portion of the program, and it wouldn't, or in the printed portion of the program, and it wouldn't probably ever appear in this class, but I wanted to make that point about zero-based versus one-based numbers and how to deal with them. Okay, so those guys just make use of that routine. And the toString, I even changed the toString to change it from a count to show the actual list. Whew. Questions about that one? Compare it to what you've got and see what works and what doesn't work. Okay. Let's go to a hockey game. Here's a driver program. I want to start out and put together a hockey team. So let's make a hockey team variable. And actually, I'm just going to call it team because you know I'm a lousy typist. What hockey team should we talk about?
Blackhawks.
Okay, so we're going to make a hockey team, and it's going to be, we're going to probably eventually have more than one team here, so maybe eventually when we've got nothing left to do, we'll talk about Blackhawks. But in the meantime, we'll start out with Canucks. So we know now that if we're going to make a team, we need a team class. So we'll make a team class. And this is all, should be old stuff to you. We'll get to the new interesting stuff in a few moments. So there's a team class. You know that the team class has a constructor. And the constructor takes a string with a name coming in, and it's going to put that into some variable to hold on to it. So we'll make a variable to hold on to it, and that variable should be declared as a private variable up there. It's going to be a string. Got it. So there's our hockey team. Well, it's made, but it currently doesn't have any players. So I guess we should add some hockey players to it. So we'll make up some word for that. My team dot add player. The thing that you're going to add is a new hockey player. We need a name here. One of those guys.
Henry.
Yeah, I know.
Must be his cousin.
Okay. So the team is going to have a bunch of hockey players added to it. And notice I don't really care to put that stuff into a variable. I'm just going to send out the new stuff. Let's see, we've got, I always have trouble with Luongo. That looks about right. And let's add one more. What's the other Sedin?
Daniel.
Wow, I thought people say didn't know anything about hockey. Okay, so there's the start of my team. Oh, it looks like we need a hockey player class also. So we'll go in and we'll make a hockey player. And a hockey player has a constructor that says public hockey player with a first name and a last name. And we'll hold on to those. And so we'll need private variables up top there. Do you remember 3 weeks ago when this stuff seemed all sorts of weird and obtuse, and now it's like, yeah, whatever, you're a boring typist. I guess we'll need some getters. And one for last name. Got it. Okay, back to the driver. We got our hockey players made, we got rid of that error message. So now the next thing is, oh, it looks like team doesn't have an add that takes a hockey player as an argument. So we'll go into team and we'll make public void add that takes a hockey player as the thing that it needs. So we're going to have a team that stores a bunch of hockey players. What do you do when you get a bunch of things?
Make a list.
Make a list. So now we know that team needs a list to hold on to all of its hockey players. So that's a list of only hockey player. And we need to make sure that that gets initialized. So that's specifically an array list that's going to be used to store hockey players. And call a constructor. And use the yellow bulb to make sure that we get the definitions, and it's the utility version of that, and the one that says util on there, and there we go. Okay, so we've got our list. So now when somebody says you got another hockey player on your team, get the list to do the work. So it can remember it for me. And I missed a brace. Got it. Oh, what to do next? Suppose that we want to see all the hockey players who are on our team. How would we go about seeing them?
Through string.
How would we just sort of print them out?
For loop.
For loop, use a for each, because that would seem to be the easy thing to do. Hockey player who in team would be nice. Who dot get first name plus who dot get last name. You're saying to yourself, why doesn't he just write a two-string? I know you're saying that. I wanted to make the point here that quite often the only reason we use a two-string is for debugging purposes, and normally in most cases when you're dealing with these things, you're just going out and grabbing the fields that you think people need to see and printing them out, just that information. So if there's other information that gets added, this is more what human beings want to see, just a first name and a last name for the hockey player, and that's it. Okay, so, oh, it doesn't look like our for each works for team. And the reason it doesn't work is, oh, sorry, that's my team. We'll try fixing that. Save it just in case. Damn, the error message isn't going to go away, and it prints that nasty thing. There's a simple fix for this.
You mean making class iterable?
You need, this team needs to be iterable. So if we go into the team and we say, oh yeah, sure, implements iterable, just like the error message says, and it's going to be only for the kinds of things we're storing, which is hockey player. That's what we said we were supposed to do. And it says, well, hold it here. You promised to do that, but you're not doing it. And in this case, we can say add unimplemented methods, and it says, oh, you need this method to fulfill that promise. And it wrote an empty one. What should the real one do? Somebody's asking us for one of these iterator beasties. Don't have a clue what those are, but somebody will give us one, because you can run a for each on an array list of things, and that works. So we'll ask our array list to supply one to whoever needs it. So we'll return all players dot, if I spell players correctly. Oh, look, it's got one of those thingies that will go give one of those gophers back to me. It might as well do the work for me. Okay? So I'm just passing on the iterator that was given to me by the array list, sending it out to whoever else asks for it. And this little pattern, by the way, you don't even need to know what it does if you don't want to. All that you need to know is if ever you want to run a for each on team, you better have said implements iterable, put that sort of similar pattern in there, and then all of a sudden for each will just magically work. As long as you have a list inside, you can run the for each on the list that's inside, and now all of a sudden that goes away, and we can print out all the people on our team. Okay, so we've got our team formed, and now all of a sudden the game starts and somebody scores a goal.
It'd be rather impressive with only 2 offensive players.
Yeah,
Since the minimum is 3.
Yeah, well, close enough. It's a shinny game. It's all we could get. So my team dot, in this case, the team scores a goal. So, and the hockey player that scored the goal was somebody who looked sort of like, I better not use Roberto. You're asking me to spell all the funny names.
This is not that hard to spell.
Daniel Sedin. Well, instead of add goal, we'll say scored goal. Okay, so something like that, except I've probably got a few too many brackets in there. Or not. Okay, so the idea is that, you know, if I'm the hockey commentator, it's like, oh, my team scored a goal and it was Daniel Sedin who did it. Well, I guess my team should collect some points for that somehow, or something should happen to keep track of this thing. So we'll go into the team class and we'll write public void scored goal. And it was a hockey player who scored the goal. Okay, so we'd like at this point to be able to walk up to whichever hockey player scored the goal, greet them, shake their hand, and say, thanks very much for doing that. And by the way, why don't you just keep track of that yourself, the fact that you scored a goal. And we'll talk about it when we get to contract season. Okay, so my first problem is I want to go find the hockey player who scored the goal. He's on my team list someplace, so it's basically like I got to go invade the dressing room at halftime to go find him and shake his hand. Okay? He's on the list, all players, so how do I go about finding him? You can talk to all players is who you've got to talk to. It would be nice if it had a search facility. It does, it's just got that silly name. Remember what the search facility is called in array list?
Compared to?
Not contains. Contains just says, are they on the list or not? Index of. So index of is really search for. And the thing that I'm going to give it is I'm going to say, hey, go find that guy wherever he is on the list. And what information does index of give back to me?
Your index.
Just where they are on the list. Well, that isn't very useful. What if I want to actually go grab the actual player?
You just punch that number into the array.
Talk to the list again and say, hey, thanks for that information, but why don't you go retrieve that person for me? And the list says, okay, sure, I'll go get them from position 5. So what do you get back at this point?
A hockey player.
A hockey player. People always think string, but remember the whole idea of making Java classes is to group information together. So when you say when you make a hockey player, you want to send a hockey player back and forth. Okay? So it's like, rather than being an intermediary and collecting little bits of information, it's better to just introduce the person to whoever you want who needs them and say, here, ask them whatever question you want. Okay, so we're typically going to send just around, work with hockey players. So this is found player. So just to give that sense that index of is finding things. Well, okay, now the question comes, how is index of actually going to find a match between somebody, if you look at the driver, who's specifically a new hockey player versus the one that's on the list where we also said new? Okay, now remember my analogy. I said that this guy is actually the 12-year-old that we're going to send into the dressing room, so it's not the real Daniel Sedin, it's somebody who's wearing his jersey. Okay, because the real Daniel Sedin actually got added to the team. This guy's never been added to the team. It's just like, hey, somebody who looked like Daniel just scored a goal. So now the issue is that when we get into the team class, index of needs to be able to match the one that looks like against the real one that's on the list. So just to be clear, I'm going to change that name from who to say this is the one that looks like the one we want. It's not the real guy, it's just the guy who's wearing the jersey, the fake jersey. What do you think index of is going to use to search?
First and last name.
Equals?
Equals. Not first and last name yet, because index of really doesn't care. Index of is the one who's just going to do the introductions. It's going to take the fake one and it's going to go to the first person on the list and it's going to say, hey, fake one, do you match the first guy in the dressing room? And it's going to leave it up to that fake guy to decide whether or not he matches the real one. Okay? So we need to go into hockey player and we need to write something that matches, and here you want to say public Boolean something like matches some other hockey player and then return true or false based on whether it looks like it's a match. Unfortunately, it's not called matches, it's called equals. Silly, silly word. So equals means looks enough like this other guy. Okay? So how would we decide if this other guy looked enough like our first name and last name?
You have to get their first name and last name.
Have to work on first names and last names. If we were really lucky,
We'd measure on the first name.
it would just match, period. Okay? Happy, happy day. It always matches, don't have to do any work. The unhappy thing, oh, I guess it might not be a match. Now I have to worry.
If it does not equals, return false.
So the way you traditionally do this is you go and you look at, take your pick, either their first or last name, and you say, if the first names don't match, we're done. Okay, so we'll write that. If my first name is the same as other dot first name, that would be a match. So doesn't match is to put the not sign on the front. You can't use not equals there because that's a function that returns a value. So you're stuck with having to negate whatever sends back. So if it doesn't match, oh, it's obviously not a match at all. Okay. Well, now you're going to say, well, okay, well, that's just first names you need to worry about. Last names, well, that's fine. In that case, if it's the last names, that don't match, still not a match. Well, fine, if it last names and first names are the same, it must be a match. That's all I got to go on. True. Okay, so you end up with something that looked like that. Notice that I didn't use the get there because since this is also a hockey player, I get the professional courtesy rule. I don't have to call the get. I can go drag out his information directly by looking at his jersey. Okay, so that's why that's done that way. Okay, well, if this thing is a standard function, in this case, I'm going to add at override on the top of it to say, I think I just wrote something that's a standard that is going to be needed by index of, and all of a sudden it complains and it says, oh, you didn't meet the standard. You're not overriding or replacing the one that's already there. What does the one that's already there do, by the way? If we're replacing one, what does the original do?
Memory address?
Yeah, it matches by memory address, or the default matching is identical. Okay? And what we're trying to do is we're trying to relax the restriction to say they don't have to be identical, they just have to be similar, look enough like each other that we're satisfied that they're the same. Okay? So the problem with this thing is that little trick that says we might be matching a cat against a hockey player. So that could actually be any old thing, not necessarily a hockey player. So it could be just not necessarily a hockey player, but just some arbitrary thing. Okay? But you'd better be passing me a hockey player because that's the only thing that makes sense. So I'm going to put this thing into a hockey player variable. So I'm going to make a hockey player variable. Oh, look, other's a good name. And now I'm going to say, well, that thing is really a hockey player. And Java is complaining and saying, no, it's not. And I'm saying, yes, it is, damn it. Okay? So that's, no, really, it's a hockey player. put it into a hockey player variable. And now that I've put it into a hockey player variable, hockey players have first names and last names, and so now I can make use of first name and last name because now I know something about what's inside of it. Okay? So equals is a little strange. And I've said the official version of equals, if you read the documentation, says you're supposed to return false for things that aren't hockey players. And I've said that that's a mistake because if you're comparing cats against hockey players, there's really something wrong with you that needs to be addressed, and you might as well just let it die and fix it. Okay? So we're just going to leave it like that, and if you ever send the wrong thing in there to try to match, it's just going to die, and you can go figure out why your program is doing something really weird. Okay? So there's that thing. Well, now, just for fun, let's go put a breakpoint in there. And let's run this thing. Are we at the point where we can run it? Oh,
Parentheses.
one extra parentheses, too many, too few. There we go. And let's, just for fun, see whether or not that equals method actually gets used. So we'll run with the debugger. And the debugger stops. Hockey players main, which is scored a goal, called teams scored a goal. Teams scored a goal called array lists index of. Array lists index of is making use of hockey players equals. Okay? So there's the proof that equals is being called even though there's nothing obvious from the main program or even from index of that says that that's what it's supposed to do unless you read the documentation. You can go see who's being compared. So there's our list of hockey players with a bunch of people on it. The hockey player that's the looks like one is Daniel Sedin, and the ones that are on the list, there's 3 of them on the list. If you crack open this thing that has the array inside of it, you can see there's 3 hockey players, and the first hockey player is Henry. So not a match. Okay? Well, just out of interest's sake, in our equals here, if we take a look, we're comparing Daniel against, if I can mouse over that one. It's not going to let me do it. Daniel against, come on.
It hasn't been parsed, has it?
No luck. Oh, that's it. We'll just do one more step over, and then it'll be a happier creature. Match or no match?
No match.
Maybe over that one. There we go. So this is matching Henry Sedin against Daniel. And so we know that it's not going to be a match because Daniel doesn't match Henry. So we'll do a step over. And there it is, returning false. Daniel and Henry don't match. Okay? So we'll just let that thing resume. Oh, we're back, stopped at this breakpoint again. This is the second person being matched on the list. So we'll do another step over. And now we're still matching Daniel, only this time against Roberto. Not a match. So we'll hit resume again, and the third time, last guy on the list is Daniel against Daniel Sedin. So this time, we follow it through. It's going to return true to say, yeah, I found a match. Okay? So we've got to the point where we know we're going to find a match for things. Let's just go back and finish this add goal off here because it's not quite done yet. So we found the matching player who was actually on the list. So that's the thing that comes back there. So now what do you want to do with them?
Record it on the player's stats.
Get the player to record it, right? Not me do the work, but we'll talk to found player. And we'll say, hey, you scored a goal. Do something about it. Well, I guess hockey player needs something that says public void scored goal. And when you score a goal, what should happen?
Goals go up.
Goals go up by 1, so that's just 1 goal. Oh, we need a goal variable up there, so we'll go back up top and we'll put private int goals, and we'll initialize goals to 0. And we're probably going to need to retrieve that information, so we'll write public int get goals. Okay. And now we're adding goals to a player. By the way, notice that it's not unusual to see the driver use a word to the team here, scored goal, and then have that same word repeated for the player later on, right? Because now it's like, I talk to the team and I say somebody scored a goal, the team manager goes, oh, I got to go find the player and say, hey, you do realize you scored a goal, right? So the words are the same, and the thing that you have to be careful of now is you always go and look on the left-hand side to ask the question, who am I talking to, in order to figure out what their responsibility is at that point. Okay? And so in this case, if you think of team as being sort of team manager, the job of the team manager is to just go locate the guy in the dressing room and go, hey, if you realize you scored a goal, you better count that, because you're going to need to know when it comes to contract season, right? They're going to want to know. Okay? So there's that idea of searching, and you're going to use that in that race cars thing. Okay? And so from now on, the rule is anytime you're searching for something, using something like index of, contains is another one. Does this list contain somebody? The thing that you send in is always a fake one, and so you got to make sure that you write that equals method in order to make sure that you find a match for the thing with the searching. Otherwise, it's just going to look like it's there and never match. Okay? So what we'll do on Monday is we'll continue with this thing, and we'll see whether or not we can start to do things like, say, who's the best player on the team, as in who has the most points at some point. And then we'll make lists of things of saying, let's go list out the team members both by points and alphabetically. And that'll be the lead in to eventually going fishing.